Okay, so in the previous classes we've been talking about different particles. So today in our discussion we are going to enhance our understanding and problem solving skills for equilibrium of particles. And specifically here, we will be discussing about the equilibrium of a particle in 2D case. And so the problem in our quiz will be pretty similar to here. Okay. So uh, given the uh, given a structure is shown in the figure on the right hand side, where we have an object that is hanging at point C. Well, we have the two cables that are connected as at the knot C here, and we are supposed to find the forces uh, within cable AC and CB. Okay, so by looking at this problem and how can we approach that? So still, remember, generally for force analysis, the first step is always to draw free body diagram. And a free body diagram is composed of the object that we are going to analyze and all forces on it, right? Okay, so specifically for the object that we're going to analyze. Okay, so what is the object that we're going to analyze here? Okay, so for particle equilibrium, what is a particle that we're going to analyze? Which part that you are going to cut out from the system and to analyze it? Okay, so you may pause the video and think about that. Okay, so the answer is particle C. Well, the reason why we go with C, it is the same as what we've been talking about in Wednesday's class. It is because, so by cutting out C, it will be exposing forces of our interest. Most here, it is the forces in cable AC and in cable BC, right? Simply because both cable AC and BC, they are connected to cables, they are connected to point C, right? If we separate that out, we will expose the unknown forces AC and CB. Okay, so step one, free body diagram. Free body diagram here. And we are going to draw the free body diagram for point C here. And please note that C is the object that we're going to analyze. And in addition to that, we need to represent all connections to C with corresponding forces. And what are the existing connections that have been cut? That is AC, represented by FAC. Okay, and CB, represented by FCB, as well as gravity. Okay, so specifically for gravity, do we know the direction? Typically, we know that the gravity is vertically going downward, right? And how about the magnitude? Okay, here we know the mass of the object. Therefore, the magnitude will be equals to mass times gravitational acceleration, right? And mass equals to 2 kilograms. And the gravitational acceleration is 9.8 Newton per kilogram. Sometimes it is equivalent to mass per square second, right? And it equals to 19.6 Newton here. Okay, that is the magnitude of the gravity. Given that information, okay, so we can go ahead to perform the force analysis based on this free body diagram C. And please note that if you stop here, if the problem asks you to draw the free body diagram of the system, okay, you've already done the job. Okay, but for the purpose of problem solving, typically, it would be good that you can include the information of the directions of the forces, and please note Given that we know FAC is along cable AC, so the angle between FAC and the horizontal direction is as in the picture, right? It is 49 degrees. 49 degrees here. Okay, for CB here, the slope is expressed by the small triangle with the base equals to 5 and the head equals to 2. So we include that here. And we can similarly express the direction of FCB by a small angle here, theta. Now please note, okay, so this small angle is related to the small triangle that we have here, and we're going to talk about that afterwards. Okay, so now we have already get ourselves prepared, and we can go ahead to perform force analysis. And the second step is to establish equilibrium of establish the equation of equilibriums, right? Establish the equation of equilibriums. Okay. Equation. Those equations of equilibriums. So what are the equations of equilibriums? Okay, so for specifically for 2D case, we know that summation of all forces along x direction equals 0. Why we can see that? It is because we know that in our class, everything is in equilibrium, which means that the summation of all external forces equals to 0. And since forces are vectors, so that implies both the forces along x direction and along y direction, they can all be zeros, right? Okay. Okay. So now if we go back here, okay, so we see that so we what so what we need to do right now is to go back to the free body diagram and also looking at the equation. What we need to do is break forces down to components, right? Because in our equation we need to have a summation of forces along x direction, so we need to decompose. We need to decompose forces into components, and I'm going to use another color here. Okay. So first draw a line that from the tip of FAC perpendicular to horizontal direction, we have it intersected with a horizontal line at a point which will be the tip of the horizontal component of FAC. We denote it as FACX. It is our horizontal component of FAC. And then the vertical line will be the vertical component of FAC, right? FAC, right? Okay. Similarly, we can decompose FCB to be its horizontal component FCBX, vertical component FCBY. Okay. Okay. So by drawing this, we have the components and the forces formed a force triangle, right? And it is a right angle triangle, therefore we can make use of trigonometry to calculate those, right? Okay, so we can use of trigonometry here. So now, by looking along the horizontal component, and what are the components that we have? We have FACX, right? Specifically for FACX, how can we find out FACX here? Okay, so we see that FACX is a side of this force triangle that formed by FACX, FACY, and FAC, right? Then FACX, moreover, it is the opposite or adjacent to 49 degrees. It is the adjacent here, right? So adjacent equals to hypotenuse times cosine, right? Hypotenuse FAC times cosine of 49 degrees. Okay, what is this? Okay, this will be FACX. Please note, FACX is going towards which direction? It is going towards left, right? And it is positive or negative here. It should be negative, right? It should be negative here. This is especially important. Okay. Okay. So in addition to FACX, what else do we have? We have FCBX, right? FCBX here. Okay. So how can we evaluate FCBX? Okay. So we see that FCBX, again, it belongs to a fourth triangle that formed by FCBX, FCBY, and FCB, right? Where FCBX is the adjacent to the small angle theta here. The small angle theta here. Okay. Okay, so the adjacent will equals to hypotenuse FCB times cosine of theta here, right? That will be our FCBX. Okay. FCBX here. Okay, so so simply it is adjacent equals to hypotenuse times cosine of theta here. But the problem is that we don't have a theta here. No worries. And please note that we have a small triangle. We have a small triangle here. Okay. So how can we relate the small triangle with this theta here? And please note that the small triangle, it is similar to the big fourth triangle here, right? The small triangle, it is similar to the big triangle, which means that this angle theta and this angle both are equal, right? It equals to theta here. Okay, which means that we can approach cosine theta from this small triangle and record that cosine theta equals to what? It equals to the ratio between the base to the hypotenuse, right? Cosine theta is nothing more than the ratio between the base to the hypotenuse. Looking at a small triangle, what is the base here? Oh, sorry. So actually, I should say that it is a ratio between the adjacent to the hypotenuse. The cosine theta equals to the ratio between the adjacent to the hypotenuse. What is the adjacent here? Adjacent to theta, it is 5, right? It is 5. It is not 2 here, it is 5. Okay. So it is 5 over, okay, over the hypotenuse, right? And what does the hypotenuse equals to? It is a summation of the squares of the base and head, square root, right? Summation of the squares of the base and head, the square root. Okay, so that right part is exactly the cosine theta that we have. Okay, so now again, positive or negative here. It is going towards the right, so it is positive. Okay. Is that all components along x direction? Yes, it is, right? So it is there. Good. Now we can go ahead to evaluate y as well. So what do we have along y direction? Now, by looking at the free body diagram, we have FACY, right? FACY equals to, again, so we see FACY, and it is in this fourth triangle here, right? Okay, this fourth triangle here, and it is adjacent or opposite to 49 degrees. Okay, so now it is opposite to this 49 degrees, right? Okay, so since it is opposite, it will equals to hypotenuse times sine. Right? It is our FACY. Okay. This is our FACY. Okay. Okay, positive or negative here. Since it is going towards upward, it is a positive, right? Okay, how about FCBY? FCBY right now since you think it is adjacent or opposite to theta here. Okay, FCBY now it is opposite to theta here, right? Since it is opposite, therefore it will equals to hypotenuse times sine theta here, right? Okay, again, to approach this sine theta, we need to go to the small triangle here. For the small triangle, we see that for the theta here, the 5 is the adjacent and 2 is the opposite, right? Okay, since the 5 is adjacent and 2 is opposite, and we know by definition sine theta equals to, it is the ratio between the opposite to the hypotenuse, right? Okay, so what about the opposite here? So the opposite should be 2, right? Okay, now it is 2. What about hypotenuse? Look backward here. It is a summation of squares of base lengths, right? And then square root. That is actually the sine of theta here, right? And this as a whole is our FCBY. Again, positive or negative here. It is positive. Again, FCBY is going upward. Is that all we have? And please note we have graphed it, right? The magnitude is 19.6 Newton, and it is going downward, so it is negative. Okay, that is all we have. Okay, and let's remove all annotations, make it clear. So now we have many equations. We have 2 equations. How many unknowns? We have 2 unknowns. Is the problem solvable? Okay, now the problem is solvable. Okay, okay, you can pause the video and try to solve the problem here. Okay, so now I'm solving the video here. Okay, I'm sorry. By solving the equations, what we have is FAC equals to 19.76. So it is 67 here. And FCD equals to 13.62. Okay. So fraction here is this rate here. That is the answer. And both are tangent. Okay. Because we solved both AC and CB, they are positive. Both of them are positive, meaning that they are tangent. Because at the beginning, we assume that both AC and CB, they are pointing away from C, which meaning that they are pulling OC. In other words, AC and CB, we assume that it is tangent. And we solved that is positive, meaning that it is consistent with our assumption. Okay, so that is our answer here. Okay, so of course, here regarding solving the equations, it's you can make use of the calculator that you have, and some of your calculators sometimes it can solve a group of equations, but if you feel that if you have to solve that by hand, but if you have any question regarding that, please reach out to me. Okay, so we can go through that. We can try to go through that in person. Okay. Okay, so if everything that here looks pretty good to you, and you can go ahead to go with the quiz. And please note for our quiz, so the condition of the geometry there, will be a little bit tricky. So there's a hint here, And the first thing is that you might want to use for law of cosine or law of sine. Try to convert that to similar geometric condition as what we have for this problem here. And second thing, again, please note that gravity is given by mass, and you need to convert mass to gravity, okay?